This problem has a race car. There's a drag car, starts right here, they're called Top Fuel. I looked that up, they are the fastest drag racing cars there are. I found out that they have an acceleration close to 39 meters per second. It's not a constant 39 meters per second, it's just an average. So we're gonna use that number and we're gonna find a couple things. We know the track that they race is 305 meters long. We're gonna find out how much time does it take for this race car to complete that track and what its final velocity would be. In the first week of physics, we don't have a whole lot of formulas to use. It's not too complicated, so I want to really stress the problem-solving method. And I learned this recently. I'd always done it, but I never called it this. It's called the guess method. And you don't just guess an answer. It's a little system. What we're going to do in this problem is the first thing we'll do is G stands for list or given. U is identify the unknowns. Well, we have those already. We know that the given the acceleration, 39 meters per second. The distance that it travels, 305 meters. And something that isn't explicitly given, you just have to know if you've ever seen drag racing before, is the initial velocity. The initial velocity starts at 0. All right, there we go, that's the first step. Now in guess, the U stands for identify your unknowns. Well, we have two. The first one is how much time passes. And the other one is the final velocity. So E stands for equations. That's going to be the more complicated part later on. We're going to have this great big list of all the equations that we know and all these things that we'll know about physics when we're in week 4 and week 5. But here in week 1, we don't have a whole lot. So that step's pretty simple. And the first S stands for solve, and the second S stands for solution. So while we're going to take a look at our equations right now, we don't have too many. If we're trying to find time, and we know the displacement, and we know the acceleration, that's a big clue right there. That equation is the displacement is 1/2 the acceleration times time squared plus the initial velocity times time. Now that might be a little bit different than the way you've seen it before. Sometimes instead of writing D for displacement, people will put x final minus x initial. So I just want to get you used to seeing this. It's kind of cool later on. All right, so we know our equation. We just plug in the givens. And that's nice. For the initial velocity, it's 0. Rearrange this, put it in my calculator, and it turns out the time is 3.95 seconds. So this is the first S where we solved it, and this is the second S, the solution. Put a box around that, check and make sure I got units on it. The second question asked, what's the final velocity of this? Well, it's a whole lot easier now that we know how much time passed. That's the equation I'm going to use this time. I'll find the final velocity because I know the initial velocity, I know the acceleration, and I know time. So I'm going to plug my acceleration in right here, plug the time that I just got right there, and it turns out the final velocity is 154 meters per second. Now, I know you're not too familiar with meters per second. Everybody drives around in this country, at least, and we go miles per hour. That comes out to pretty close to 340 miles an hour. So that means that drag car goes from 0 to 340 miles an hour in 4 seconds. All right, there you go. That's the guess method, and we'll be seeing that the whole way through the course.